This lesson we start using Pandas data frames and series objects in Python. It's a little more difficult to use than R's data frames. I think it may be a little bit more powerful, but I'll let you decide that. Let's get started with some data. But before we jump in the data and sort of see what it looks like, let me just show you what the Jupyter Notebook. I'm assuming that you guys are going through this Jupyter Notebook. This video will not cover everything in there. Vanderplas book is a reference for you, but that Jupyter Notebook has everything that he talks about in that book. So if you go through the Jupyter Notebook and you understand what's going on in there, you'll be more than, at least you know where things are at is kind of what I'm looking for. You don't necessarily know how to remember every little single command that it can do, because Pandas is pretty powerful. It's got a lot of little things, little nuances that come with it. So just know where things are at in order to be able to reference them. And the Vanderplas book is you can just open it up and check out the text in there. The things that the Jupyter Notebook will cover are these four things here, and we're going to do. I mean, the first one will be the first reading will be this one, and then the next reading will be that one, and so on and so forth. Okay, so let's look at the data that we're about to pull in. So in my or on the course website, there's all of, I think I zipped it up, but there's all of these data files, or basically text files. We're going to bring these things in, and all it is year of birth, 1880 is what that stands for. And inside it has all the names, and I think it's ordered numerically from the most names. So for example, I'm sorry, first by females and then by males. So you have female, Mary, name 7,065 were in the year of 1880. Anna, female, 2,604, and so on and so forth. And you can see all that information there. And then 1881, if you were to open it up, you can see Mary and Anna still at the top of the list, and I think maybe Emma wasn't. Anyway, bottom line is this is all of the years from 1880 all the way until 2018. So that's the data that we're going to pull in. We're only going to pull in today. This video, we're only going to pull in 1880. So we're only going to be worried about this set of data right now. But in the next video, or at the end of this video, we're going to figure out how we can pull all this data in at the same time. So let's jump to it. The standard packages, right? So Pandas, NumPy, and Matplotlib are our standard packages. And then the way we're going to build this is we're going to start off by just seeing years equal to 1880, and then putting year inside the way to access that data. So let's see, F9, and then DataFrame is equal to pd.readTable. I think this sounds like something that you would be doing in R, read table. And then we're going to pass in file because I just named it right above it. And then the separate SEP, it tells it how things are separated in the file. And in this particular case, it's a comma. And then we're going to tell it the names of the heading of each column. So I'm going to let names be the first one. Let's go sex be the second thing in each one of those lines, and then number. And so we're going to do that. So let's see what happens when we hit F9. And it looks like it worked. So there's 2,000 pieces of data in there, and there's three. There's a name, a sex, and a number, and you can pull it up, and you can see name is Mary, sex is female or male, and number is the number that was associated with it. So it's just that easy to bring in a data frame. If you have a file, and that's generally how you will do it if you're given some data, right? So very rarely, if you're going to use a data frame, are you just going to be creating it yourself. Most of the time you'll be importing in it as a file, because Python has so many other ways of handling different types of data that there's really no reason to use a data frame for something if it's just something very simple. So again, data structures, right? I know we talked about that before. So let's look at, one other thing that we want to do is make sure that we bring in year, because why? in the future or later on. So acquire, so you see it here at the bottom down here. At the end, we're going to pull in all of the years, right? So I'm going to let it be YR. So all this does is it adds another column to this data frame, and it calls it year. So year will be the next, will be the column name, and then every single value that's in there right now is going to have the string 1880 associated with it, and that's what we want. So if I bring up, I probably should have capitalized it. Let's do that again. Let's capitalize it just to make it the same as the other ones. I don't know why I didn't capitalize it. I mean, if I had all lowercase here, I would want all lowercase for all of them, but we want to make that standard. Okay, let's see, number. So what if we wanted to find out something like the number of males and females who were born in 1880? Well, we could certainly get and start adding up all of the numbers. Where's the F stop? So the F's stop and the M's start here. So we could go with an all 941. So I could write a for loop that would go through, and it would, if sex is equal to F, then it could add it to. I mean, we could certainly do that. There's no reason to, because obviously this is in a data frame, and so we should be able to do things a little bit quicker. So we're going to say df.group by. So group by is something you will learn in a couple lessons. We're going to group by sex, and then I'm going to tell it to sum. So all I did was I said group by the column sex and then dot sum. Now this you might think that it's going to sum up all of these things, but it's only going to sum the things that are actual, that it can actually sum. For example, it can't sum name, right? That doesn't make any sense. And so you see that sex F is 90,992 and males are 110,491. So you can see the number that was born in that particular year of 1880. What if I wanted to find out here? Let me do name is equal to. I'm going to use my name, my first name, or I should say my middle name, not Grover. My first name. I'm going to use my middle name, and then we're going to say df of name. So now what I'm doing is creating a Boolean mask. So if we did that, I didn't. We're going to get a lot of zero. Matter of fact, you're going to get all falses except hopefully one. I mean, it could be that there is no Jake that was born in 1880, but I think there's going to be one. So now I need to find out. We need to use this. So that's the Boolean mask, and then I'm going to come back here and go, well, basically print it off. I mean, I could put a print statement here, but doing that will print off that row, and that row is 1080, the 1082nd row, because there's not very many of them. There's only 96 Jakes born in 1880, and they're all males. So, but surprisingly not enough, there are some years where some female Jakes were born, but we'll see those in the future. Okay, so that's how we get at that. What if I wanted to come back and say, well, tell me, let's create another Boolean mask when number is greater than 2000. So give me all of the ones where number is greater than 2000. You can see the first three of the females, and there's probably some in here, but let's get them printed to the screen. So df F9, and in this case you see that the first three are Mary at 7065, Anna at 2604, Emma, and then there's a whole bunch of males that were born. Does that make sense? Let me see how many males and females. Where's my numbers? So there are more. So 90,992. So there's about 20,000 more, about 20,000 more males and females. So maybe that makes sense. Maybe it's just that females have a lot more names that were sort of more dispersed than males. It looks like 942, and was there 2,000? Maybe that's not the case. Anyway, so What if we, yeah, let's change this to, what if I wanted to not only figure out, let me get rid of this real quick. Not only, how about 1,000? So I want to know all the female names that's more than 1,000, maybe something like that. But what I tell you is you got to put a parenthesis around this, and you got to put the bitwise and then another parenthesis around it, and then df sex. And you got to put the really equal to sign, the one that tells if it's true or false, and then we want it to be female, right? And if I did this, it should give us a Boolean mask, and it does. So you can see that only the ones at the top up here where they're females. And then what you do with the Boolean mask is you pass it in as an index. So pass it in as an index, F9, and you can see all of the females. You could have probably got this just by doing, coming up here and going, all right, well, it's right there, right? So Laura should have been my last one, and then Laura should be my last one, right? So, but this is a way to get at it if they're not sort of lined up the way that you want them to. All righty. Let's see, what else do we need to talk about? What about this one? DF describe. What if we want to describe, so just like we talked about a second ago when we did the sum, in this case, the describe is going to give you sort of some summary statistics of the columns that only have numbers in them, right? So the only one that's going to talk about is number. Year is a number, but it's not really a number, right? Because we passed it in as year, YR, which is a string 1880. So it might look like a number, but it's not really. So let's pull that up again. So you can see this is sort of misleading because when you get like like in a second, when we pull in all the big giant data frame that has every single name from 1880 all the way to 2018 or 19, I forget what our last year is. I think even these numbers are going to be white, but right now you can see that these are sort of colored, indicating that there's some kind of number there. Okay, so let's do it. Let me show you that that's true. And so if there were other numbers on here, it would sort of give you the same thing: the total number count, the mean of it, right? So the middle, the standard deviation, the minimum, the 25th percentile, the 50th percentile, the 75th, and whatever the max is. So you can see the 75th percentile of all the names is only 41. So that means 25% of them are, even more, way more than that. So in other words, there's most of the names only have 41 or less actual people who are named that. There's very few that has a whole bunch of, 20, that's 25%. So I mean, we could go and do some percentile stuff, but I'll let you guys worry about that in the future. Okay, so acquiring all of the data. Suppose that we wanted to acquire all of the data in our file. In this entire, oh, I'm sorry, before one more, I'm going to do a histogram. So let's do a histogram. So df number dot hist. So the neat thing about pandas data frames is it has these. So remember, this is an object, and this is actually a series object. So if I just pull out one column number, I guess I could spell that correctly, actually work. If I pull out just one column out of this data frame, that's actually a series object. And if I did a histogram on that series, then it would give you something that looks like this. So you can very quickly just sort of tell what's going on just by pulling this out and looking at it. I mean, you could do this kind of the same thing here. And let's see, let's go number. Let's see, df. I'm going to put df number is greater than 1,000. All right, so this is a Boolean mask, and then this is just histograms, all of them. So if you just look at all of so there's only 18 that have, less than 2,000 names. I'm sorry, 18, yeah. There's 18 of them that are greater than 1,000, right? So there's 18 of them that lie here that's between 1,000 and 2,000 names. There's 8, it looks like, that's between 2,000 and 500. I'm not sure what the bin number is. We could probably get that if we wanted it. And then there's very few, maybe, what does that look like? Maybe one or two. It's probably one, and that's probably one, and so on and so forth. Right. So there's very few that sort of lie out here in the eaches. But histogram, it gives you a chance to sort of look at the data very, very quickly. Now let's go to this part about creating this function that's going to square us away. So I'm going to call it append data. And all we're going to pass in is the year and the current. I'm going to call it the old. I should probably call it the current data frame. And what are we going to do? Well, I got to create the file name first, and it should look a lot like it did up there. So I can come up here and copy this thing. Control C, Control V. So all we're doing is taking year and pop it in there. So those should be equivalent. And then DF. So again, it's going to look just like this one. Matter of fact, all of this stuff is going to kind of look the same, except I got nothing hard coded in. So year comes in, and year goes in there, then file comes in, separate, yeah, everything stays the same. Capital year is year, and then all we've done so far is we've passed in the current data frame, and what I want to do is I want to take whatever the current data frame is, and I'm going to concatenate or append the new data frame, the one that we just pulled out. So this is the DF, the one that we just sort of read from the table. And now I want to take all of that information and I want to put it at the bottom of the current one, if you will, to create a new. So new data frame is equal to pd.concat, and I think you get this next lesson, the concatenation. And all you do is you pass in the old data frame and the current. Actually, yeah. I'm going to call that guy the old data frame. I'm going to call this guy the current data frame. And when I put them together, it's the new data frame. Okay. I should probably call this current CUR, but I'll forget somewhere to redo that if I do that. And then the thing that we're going to return is just the new data frame. And what that's going to allow us to do is put in a new year, 1880, then 1881, then 1882, and this thing just keeps sort of concatenating it on the bottom of the old one. And then in order for that to work, I got to do this. I got to say, well, years is equal to, let's see, I'm going to make a string of year for year in range 1881, because we don't want to start 1880 because we already have 1880. And then we want to go all the way to 29. Maybe. Let's find out what that does. Find out what years is. So it's going to pass in everything 2018. Let me just make sure that we have 2018. Yeah, I don't want any errors. And so if we have that going for us, then we can say for year in years. Notice how I did that. DF is equal to append data. So you got to put in the old, or the year, I should say, and then the old data frame. So just like A is equal to A plus 1, this one's going to DF is equal to append data. Should that be 2 P's? I think it should. More sense. All right, let's highlight this and execute it. And then we remember data frame was 2000, and when this thing stops running, it'll be much larger than 2000 because it'll have all of those years between 1880. Oh, there we go. So we have 1,956,398. So if I double click this, which I will in the next video, you'll see that that this thing is pretty big, and it takes a second for it to come up. Okay, that's all I got. I hope you guys got something out of this one, and we will see you next time.